Sequences as linear functions. It sounds scarier than it is. So go ahead and get started on this practice problem. Yes. All right, so we should have gotten B. What do we mean by constant of variation, really? Slope. So it's just finding the slope again. And who can remind me how I find slope? Alex?
So you have to do like the x minus the y. No, like the, -3 minus the 12.
So y minus y over x minus x. Changing y or changing x. So -3 minus -12 over 2 minus 8. What happens to the negative? Becomes a positive. So -3 plus 12 is positive 9 over 2 minus 8, -6. Can I reduce that? Divide them both by 3, and what do we end up with? -3 over 2. Okay, so it's just finding the slope, change in y over change in x. All right, go ahead and try this one. Okay, well, which ones can we get rid of right away? A and B. Why? They're positive. When you read this from left to right, this is going up. Those are gone right away. What's the slope of this? -2 over 1. What does that mean? Down and to the right is one way to think about it, because down is negative and right is positive. So down 2 and over 1. Down 2 and over 1. If we look at this one, that one works. So it has to be C. What would the slope of this one be? -1. Okay. Could you also, for a slope of -2 over 1, can you also go up and to the left? And why is that negative? Because up is positive and left is negative, so that's still a negative. But no one should have answered A and B, because what are these slopes? Positive. Okay? So be careful. Make sure that you remember that part of it. All right, try this one. All right, pretty good job on that, guys. So what's the first step here?
You need to do y equals kx.
Y equals kx. Great, that's a direct variation equation. We know our y and we know our x. So 32 equals k times 8. Divide by 8, so what does k equal? 4. So y equals 4x. That's your actual direct variation equation. And then it tells us what is x when y equals 64. So we're going to plug 64 in for y. So 64 equals 4x. Divide by 4, so x must equal 16. Awesome. All right, try this one. Some more direct variation. Okay, pretty good again. So y varies directly as x, so we've got to put it in our y equals kx. Y is -24 and x is -3, so what do we have to divide by? -3. And -24 divided by -3 is +8. So you got to be careful with your negatives. So we get y equals 8x. And then it tells us that x equals -2, so we plug it in for x this time. So y equals 8 times -2. So what was y equal? -16. So be super careful with your negatives and your positives too. Okay, good. All right, so moving on to the lesson, an arithmetic sequence. Okay, arithmetic sequence. What does arithmetic mean? That's where we'll start. What does arithmetic mean? What do you think, Colin?
Arithmetic sequence is a numerical pattern that produces or decreases at a constant rate called common rate.
Arithmetic. What's arithmetic?
Math.
Adding, subtracting, stuff like that. Okay, it's math. So what we're doing with arithmetic sequences is we're finding the constant rate. Have we been working with constant rates this whole chapter?
Yeah.
Slope, constant of variation. It's the same type of thing, okay? And it's called the common difference. So if we look at this pattern, 3, 5, 7, 9, 11, what are we doing from each stage? Adding 2. So when we're talking about arithmetic sequences, we're talking about adding and subtracting in the pattern. Not multiplying and dividing, only adding and subtracting. So the common difference, or the D, will be 2. Because what are you doing each time? You're adding 2. So we're really working with patterns and finding what their common difference is. So if we look at the next one, we go 33, 29, 25, 21, ... What are we doing each time? Minusing 4. So the common difference, the D, is negative 4 because you're subtracting each time. All right, so here's an example. So we've got negative 15, negative 13, negative 11, negative 2. First, we need to decide, is it an arithmetic sequence? Why would this be an arithmetic sequence?
Because it has like a pattern.
It has the pattern. And what is the pattern? It's adding 2, plus 2, plus 2, plus 2. So D equals 2. So yes, it's an arithmetic sequence because we're adding 2 every time. It's the same thing that we've been doing with the constant. Because this is really what? The constant of variation, kind of. It's the slope. Okay, so sometimes we get a little bit harder with some fractions. So we need to determine whether this is 1 or not.
It is. Because it's minus 4 on the top.
So,
Oh, wait, no, it's not. It's minus, no.
so they're all the same denominator, right? One way to think about this is if you start with this one and subtract away this one. So what's 5 eighths minus 7 eighths? Negative 2 eighths. Okay? Now, let's look at this one and this one. What's 1 eighth? That's a bad color. What's 1 eighth minus 5 eighths? Negative 4 eighths. Are those the same? No. So this is no, it is not an arithmetic sequence. So if you're not sure, you can always take one and minus the one in front of it and do another one, take it and minus the one in front of it. And if you get the same thing, then it is 1 and you have to find the constant of variation, or the D, which is the common difference.
Oh, so they should be the same.
They should be the same. So since these are not the same, they don't have the same common difference.
Okay.
Because this one you're minusing 2 eighths, and this one you're minusing 4 eighths. So that's not the same common difference. All right, try this one. All right, let's see how we did. This one was a little tricky. Okay, so if you're given this many terms, you have to look at all of the terms given to you. How do we get from 2 to 4?
2.
We add 2. How do we get from 4 to 8?
4.
We add 4. We're done. There's no common difference because we added 2 and then we added 4 and then we added 2 and then we added 2. They have to be the same throughout for it to work. Yes, Marco? No. Nope. It has to be the same thing every time. Yep. So this one was a kind of tricky one, but for me, you got to be really careful. You got to look at everything. What are we missing? A 6. If the 6 was in there, would it have been? Yes. Okay. All right, try this one. All right, let's see how we did. C. What's 2/3 plus 1/3? 1. What's 1 plus 1/3? 4/3. What's 4/3 plus 1/3? 5/3. And if you couldn't do this, you've got to do some math. So if you do 1 minus 2/3, you find the common denominator. That's 3/3 minus 2/3. That equals 1/3. Okay? So maybe do it for this one. 5/3 minus 4/3. What does that equal? 1/3. Are those the same? Yes? So it does have a common difference. And its common difference is 1/3. You're adding 1/3 each time.
Can you just put 1 or would it have to be 1/3?
It would be 1/3 if we, for the final answer.
Okay. Like
So this is just asking us, is it an arithmetic function? Yes, it is. If we were saying, what's the common difference? The common difference would be 1/3. Okay. So now, deciding whether it's a common difference or not, we need to find the next terms in the sequence. So, -8, -3, -4, -8, -11, -14, -17. Is it an arithmetic sequence?
Yes.
What are we doing each time?
Subtracting.
Subtracting 3.
Yes.
Subtracting 3. So we're trying to find the next 3 terms. So what would the next one be?
-20,
-20,
-23,
-23,
-26.
-26. Exactly. So we're working with patterns and finding the next steps of the patterns. Okay. Go for it. All right, what are we doing each time? Adding 5. Awesome. We got it all right. Great job. All right. So, this formula, the nth term of an arithmetic sequence. The nth term means any term that you want to find. So you could find the 100th term, the 250th term. If we had to write that all out, would that kind of suck? To write up the 250th term. So we're going to learn a way to find the 250th term with a formula. You do not need to memorize this formula. I will be giving it to you. But write it down for your notes. So a sub n, that means the nth term, equals a sub 1 plus the parenthesis n minus 1 and parenthesis d. Okay? You do not need to memorize this formula, but you do need to know what the things mean. So this a1 is the first term. That's why there's a 1 there. So it's the first term that you plug in. It's the first term in the sequence. So like the first number in the sequence that you see. N, you won't know. N is like any number you can put in. So n would be your number, but you're not going to put anything in for that when you're writing the equation. And then we already learned what D was. What was D? The difference, the common difference. So your pattern, right? Common difference. That's funny looking, but that's okay. That's the D. That's what you find. So, write an equation for the nth term of the arithmetic sequence. So what's our first term when we are looking at this sequence?
1.
Okay? And what do we need to notice? What else do we need to find?
9.
What are we doing each time? We're adding 9. Okay? So each time we're adding 9. So when we have our formula, a sub n equals a1 plus n minus 1 times d, this is what we're solving for, so that stays the same. What's a1? 1. So we get, bad color. A sub n equals 1, because that's our first term, plus n minus 1 times, what's our d this time? 9.
Oh, when you
And now, go ahead, sorry.
this actually is on the
You want to ask in a second? Okay, so now that we have this, what do we need to do you think?
Solve.
Simplify it, solve. But we're just going to simplify this right-hand side of the equation. So a sub n is going to equal 1 plus, what do I have to do here? Distribute 9n minus 9. So the formula is a sub n equals 9n minus 8. What's 1 minus 9? I'm just simplifying that.
Oh, is that just the term?
Yeah, you got to combine your like terms. You distribute and then combine your like terms. So what this means, so try it out. If we plugged in 1, we want to find out the first term in the sequence. So if we plug in 1, that's the first term in the sequence. 9 times 1 is 9 minus 8 is 1. Did we get out 1? Was that what we wanted? Okay. Second term in the sequence. Plug in 2. 18 times 2. Sorry. 9 times 2 minus 8. Is that what we had? Yeah. So you've actually just written an equation for that pattern. You're using this pattern and then writing an equation for it. So now I want to find the 12th term. It would be a bummer to have to go and write all these out to the 12th term. But now that you've written this equation, you can find the 12th term. So in this case, n equals 12. The number term that you're looking for is the 12th term. So you plug it in, exactly. So a sub 12, because you're plugging in 12, okay, the n is 12, equals 9 times 12 minus 8. So a of 12, so a sub 12, when we plug in 12, 9 times 12 is 108 minus 8. So a sub 12 is 100. So if you went all the way up to the 12th term, it would be 100. Could you find the 100th term? The 1000th term? Yeah. And that would really be a bummer, right, if you had to write it out. So this, finding this formula is an important part of it. Okay. Does this look like things that we've been working on? Yeah. So when we plugged in 1, we got out 1. So that would be 1 comma 1. When we plugged in 2, we got out 10. And do we notice, is this a linear equation? Yeah, so it all kind of relates together. Okay? And we'll get to actually, we had a sub n equals 9n minus 8. We'll get to graphing that just from knowing this next chapter. Okay? Okay. It's just the same thing. Which term in the sequence is 172? So let's rewrite out our an equals 9n minus 8. So this time, what are we actually plugging 172 in for? Is it asking for the 172nd number?
No, it's saying like what is.
No, it's wondering which term. So it's actually wondering n. We don't know n right now. It's wondering which term is equal to 172. So we actually know this part. We know the final answer is 172, but we don't know what term number it is. So this is going to be 172 equals 9n minus 8.
But the n goes like a normal.
The n doesn't go away. What are we doing?
No, like on like the a.
Yeah, because that does go. So a sub n, we know the final answer. So what do? We add 8. We get 180 equals 9n. Divide by n at 9. So the nth term, it would be the 20th term in the sequence. If you plug in 20 for n, you get out 172. Okay, so n is our term. N is the term we're plugging in, and it's equal to the final answer, what you would get out.
Could you do up 1 over 9?
No, because the common difference wasn't 1, it was 9. Okay, so the arithmetic sequence 2, 7, 12, 17 represents the total number of pencils Claire has in her collection after she goes to the school store each week. Write an equation for the nth term of the sequence. All right, try it out. Using the formula, an equals a1 plus n minus 1 times d. Using that formula, because I'm not going to make you memorize that. Pretty good job, guys. So we're finding a sub n equals, what's a1 this time? 2 plus n minus 1 times, what's our common difference? 5. Distribute a sub n equals 2 plus 5n minus 5. So an equals 5n minus 3.
Here's my question from a while ago.
So if it's like just like 5, like, and then in parentheses like 8 minus 3 or something, how would you know whether to do like 8 minus?
Question. Okay, so a sub n equals what we have, 5n minus 3?
Yeah.
Okay, so now we're using that formula to find the 12th in the sequence. So, you're trying to find the 12th term. You have to remember that n is your term. So it's an equals 5 times 12 minus 3. So that's 60 minus 3, which is 57. Okay? This time, which term in the sequence is 97? Which term in the sequence is 97? Use your notes. It's all in there. So this time, pretty good. This time, we want to find which term, so we don't know n. So we say 97 equals 5n minus 3. What do? Add 3, so 100 equals 5n. What's 100 divided by 5? 20. The arithmetic sequence 12, 23, 34, 45 represents the total number of ounces. Write a function to represent this sequence. What are we doing each time? Adding 11. So the way we write this out is f of x equals 11n. This is a function. F of x. We've gone over some function stuff. Is this the same as like y equals 11x? Yes, it is.
Oh.
Y and f of x are the same thing. This is just how you write it as a function. And what are we doing? Oh, it's not 11n. That was silly. Sorry. It's not, because what do we have to do? A sub n equals a1 plus n minus 1 times d. Yeah, sorry, that was my fault. An equals, what's our first term? 12 plus n minus 1 times 11. So a sub n equals 12 plus 11n minus 1. So a of n equals 11n minus plus 11. So this is actually a function, but another way that you can write it is f of x equals 11x plus 11. Okay? Just putting it in this form. Or you could do a of n equals 11n plus 11. This is another way you can write it. It's just writing it the same way, but putting those parentheses, because that's what we plug in.